webinar by Dr. McLachlin to educate our surrounding areas and bring all the surgeons together. Unfortunately, over time, the meetings just start to die off and stop. And this is one of the advantages of the pandemic, that we've changed education around, and we thought it was a good opportunity to bring SWASA back. So we're really excited to get this started on a monthly basis. Today's our first session. We do have recordings of all these for the future. So as we go along, make sure that there's proper privacy. And then we've got a great presentation this morning. Afterwards, we'll have a question and answer. You can put the questions in through the chat as the presentation goes. And then at the end, we'll also open it up to discussion. So I'd like to welcome Dr. Vivian McAllister, who's coordinating the resurgence of SWASA virtually, to introduce our guest speaker today.
Thank you. Just checking my mic is on. So it's a great pleasure to introduce Des Leddin. I'm a good person to introduce him because I know him probably longer than anybody in Canada, other than his wife. Or maybe longer than Liz, actually, Des. That's true. But we were in Trinity College together. Des comes from a political dynasty in Limerick in Ireland, and indeed his brother is in government there. So if you need anything done in Ireland, just ask Des. And he, in Trinity, was a year ahead of me and a star pupil. For the residents and trainees on staff, just to tell you how we had it, we were in small hospitals in Dublin, and we actually lived in the hospital for nearly 3 years, which was a fantastic introduction to medicine. Des and I came to Canada 40 years ago. Des went to Kingston, where he was a resident in medicine and gastroenterology. He has a fellowship of the Royal College of Physicians in Ireland, as well as the Royal College of Physicians and Surgeons of Canada. Most of his career has been in Dalhousie, where Des, I think you've been there nearly 35 years or maybe longer. Yep. And he's made an extraordinary mark down there, where he is Mr. Gastroenterology. But also throughout Canada as a leader in gastroenterology. He's been president of the Canadian Gastroenterology Association, as well as having a leading role in the World Gastroenterology Association. Towards the end of his career as a teacher in Dalhousie, Des started to look at global issues. And the first thing he was doing was undertaking training in less privileged countries, which is difficult for high-tech medicine such as gastroenterology. So he was teaching endoscopy in Bolivia. And then through that organization, he's become interested in global warming and global issues. And that's what the talk will be on today. Des, before we start, I think Christine is going to try and show a poll. Is that possible, Christine? So while you've got a minute here just to answer your question, it's what is the most suitable completion of that sentence? Global warming is important to me, to humanity, and pick one of the four there. And then while I give that 1 minute to be done and submit it, I'll just tell you that we have purchased now www.swasa.ca, SWOSA, swasa.ca, and we'll be keeping information about upcoming talks there, as well as recordings of past talks. So Des, thank you very much for offering to give the inaugural SWASA Grand Rounds.
Great, thank you, Vivian, and thank you very much for the opportunity to speak to you on this. I'm just going to switch over to sharing my screen. Which might take a moment.
I'll stop. There we go.
We're good. I'll just switch this to speaker mode. Is that okay, Christine?
Yes, I can see it.
Okay, great. Thank you. Good morning, everyone. And again, thank you very much for the opportunity to speak to you about this. I'm nervously awaiting the results of your poll because I suppose we can compare pre and post, but we'll see. So what Vivian asked me to address was how might climate change impact surgery. And the messages which I have for you are here, which is that climate change is well underway. Hard it is to believe in a Canadian winter, but there we are. It is a major health issue and surgical practice will surely be affected. But physicians need to get more involved in this. It hasn't really been seen as a public health issue yet, and we need your leadership to help drive the change. So the outline of what I'd like to talk to you over the next 20 minutes or so is why surgeons should engage on this topic, then a little bit of background on climate change, the science of it, and then we'll move into climate and health and how those two are related, postulate what the impact on surgery might be, and then we're going to compare 3 operating rooms in terms of their carbon footprint: the Vancouver General, the University of Minnesota, and the John Ratcliffe Hospital in the UK. And then finally, we'll touch on what we can do and how we might be able to do it. So I have to tell you, London was way ahead of the game on this. And this is a very, very good paper, which deserves to be reread by anyone getting interested in this area. And it came from London. Vivian, I don't know these faculty, but I'm sure you do. And Yon Kagoma was the lead author on this, published in the CMAJ in 2012. It's a beautiful piece of work. The references are as relevant now as they were then. And, you know, they were emphasizing the classic reduce, reuse, recycle, rethink, and research. And with regard to reduce, we're going to touch on some of this, particularly with regard to the issue of biohazardous waste versus non-biohazardous, the switching over to LED lights, reusing single-use items, recycling and rethinking, especially the very potent greenhouse gases, the anesthetic gases. So I'd recommend this paper to you if you're going to dive into this area. And fast forwarding from 2012 to 2021, this paper just came out, this note just came out in Doctors Nova Scotia Journal from St. Martha's in Antigonish. And he too, Mike Brennan, has been working in this area for over a decade. And the point that he would make to his fellow surgeons is that Canada's healthcare system accounts for about 5% of total greenhouse gas emissions in the country. And since Canada has one of the largest carbon footprints in the world, that's a very significant contribution. 80% of waste occurs before the patient enters the operating room. It's plastic and wrapping and cardboard and stuff. And 85% of OR waste is seen as sent as biohazard when only 15% is actually biohazardous. And when you throw stuff in the biohazard bag, it goes for incineration, which is much worse than landfill. So you're adding even more toxic material to the atmosphere than if it was simply buried. And 50% of waste is recyclable. So they've been working on this for a while, and they formed some very interesting partnerships. One of them with a local company here, Greenwood, and they've taken these ubiquitous plastic drapes, the blue drapes, which are a huge source of waste in the operating room, and they're making them into lumber, plastic lumber for decks. And that's just a local company that's doing that. So with regard to the question of why surgeons should engage, well, I think I'll convince you we are in a climate crisis, and crisis is not too strong a word for it. Healthcare is a major contributor. Surgical suites are a high source of greenhouse gases, perhaps as much as 20 to 30% of all hospital waste, and high energy usage because of the need for temperature control. And we need your leadership. And finally, it's in your own interest because change is coming, and you'll either shape the change or you'll be on the receiving end of it. But one way or another, it's going to come over the next perhaps 5 to 10 years or so. It seems London is well set up to do this. You have, I believe, an ecological stewardship program. I don't know how active that is, but the infrastructure is in London, I think, in Southern Ontario to make those changes. So let's just back up a little bit for a minute. And having, I hope, convinced you why surgeons need to engage, let's just look at the background to this. And at the background of it is human activity, which is the number of us times the stuff that we're doing. And humans are driving climate change. The evidence for that is unequivocal. And the same things that are causing climate change are polluting the atmosphere and the oceans and the land. It's the same stuff. The consequences of these two are that we're decreasing biodiversity dramatically. And now the circle is complete and it's beginning to impact negatively on human health and on the course of the health of other species on the planet. So this is Lucy, who is the mother of us all. I've had the chance to see her in Addis Ababa. And she is thought to be, she's the earliest ancestor of humans. And there's Boris Johnson, and you can see how we've evolved so dramatically over 3 million years. So Lucy was found about 3 million years ago. And at the time, we were just another species of ape, and not many of us on the earth at all. And even 10,000 years ago, there were only 2 million humans. At year 0, that had grown to 200 million, which so we'd increased a fair bit. By 1800, 1 billion, and the projection for 2100, who knows, somewhere about 8 to 9 billion. And I think we can reasonably argue that the planet just cannot sustain this level of population. It's too much. And we're wiping out everything else. So of all the mammals on the earth, 36% are human, 60% are farmed for human needs, and only 4% are left. So diversity is being eroded dramatically. Similarly for birds, only 30% of wild birds are left. So is this a big deal? It possibly is. And you can draw a fairly direct line between the current pandemic and some of the encroachment which we're doing on wilderness areas and on biodiversity. Nova Scotia has a big answer or question to answer here in terms of the whole pollution and climate change stuff. And the person who's responsible is Abraham Gessner. And he was a Nova Scotian. He studied medicine at Bart's because his prospective father-in-law wouldn't leave him marry his daughter unless he had a suitable profession like medicine. So he went to Bart's, but he didn't really care about medicine that much. He was really into geology. He returned to Nova Scotia and worked as a family doctor, and he noticed people burning rocks up in New Brunswick, and the rocks were called albertite after Prince Albert. And in 1846, Abraham Gessner refined kerosene from these rocks, and that is really the start of the petrochemical industry. And thanks to Abraham, we've never really kind of looked back at the atmosphere, the planet has never really looked worse. So at the moment, the consumption of fossil fuels is 171,000 kilograms of coal, 116 million liters of gas, and 186,000 liters of oil. And you might say, well, per what? Per week, per day, per hour, per what? No, that's per second. So this is the amount of fossil fuel which we're burning at the moment per second globally. And we're pouring this stuff into the oceans and into the atmosphere, and it just can't go on. So you say, well, what does this mean exactly? Well, current consumption of fossil fuels is 51 billion tons per year. So that's roughly 1 billion tons per week, or 1,000 million kilograms per week, which is 600,000 million liters of carbon dioxide per week put into the atmosphere. And by the way, if you believe Bill Gates or David Attenborough or the scientists on this, we need to get this to zero by 2030 or 2050 at the latest. I keep checking this number over here, the 1 kilogram of CO2. apparently yields 600 liters of CO2 gas. It sounds unbelievable to me, but that's what I keep coming up with. And that's what 1 ton of CO2 looks like. If that's a London bus and that's a balloon filled with carbon dioxide, 1 ton is a balloon with a diameter of a London bus of carbon dioxide. So we're putting incredible amounts of this into the atmosphere. And not surprisingly, it's led to an increase in CO2 levels in the atmosphere. So this is carbon dioxide concentrations in parts per million from 150 to 400. And this is years from 800,000 years ago to the present day. And we know about these levels from ice cores that are drilled in the Arctic and the Antarctic. You can drill down a couple of kilograms into the ice and then analyze it for CO2. So you know what the levels are. And you can see that over the millennia, carbon dioxide levels go up and down. And they do, and it coincides with mini ice ages and warming and so on. But they have never exceeded 300 parts per million until we arrived. And here's the current level at about, it's actually, I think, 415 today, parts per million. So we have driven this up like a rocket. And there is no time for the planet to adapt to this or try to deal with it. The speed with which we put CO2 up is absolutely unprecedented. We talk a lot about CO2, and that's important because it's about 65% of greenhouse gases. Once you put it into the air, if you burnt carbon today coming into work in your car, that CO2 that went into the atmosphere is pretty much there forever. Once you've released it from sequestered biofuels, it's there. It's not going away. It's the global standard, and it's assigned a global warming potential of 1. But there are other gases, and our friends, the cows, burp it and pass it from the other end, methane, about 16% of greenhouse gases. It lasts for 12 years, but it's much more potent than carbon dioxide. It's 28 times more potent. And nitrous oxide, which is released as part of making concrete, lasts for 100 years and is 265 times more potent than carbon dioxide. And the fluorinated hydrocarbons, lesser amounts, last for 100 to 50,000 years and are 15,000 times more potent than carbon dioxide. So how do these gases actually cause the atmosphere to warm up? Anyway, well, the energy comes into us from the sun. Some of it is reflected back by the atmosphere and by clouds, and some is reflected back from the Earth's surface, particularly from snow and ice. And that's important because as the ice caps disappear and the underlying dark water appears, less of that is reflected back into space. But some of the energy coming in is absorbed by the land and by the oceans. And the wavelength of the energy changes to the infrared spectrum from heat and is reflected back out. And most of it goes back into space, but some is absorbed by the atmosphere and by clouds, and that is where the problem comes in. So if we switch over here to a molecule of carbon dioxide, what happens is the infrared energy is able to give more kinetic energy to CO2. And each molecule of carbon dioxide then effectively acts like a little heater. So the more carbon dioxide we put into the atmosphere, the more little heat storage units we have floating around the Earth. It's not exactly like a glass house, but the analogy has stuck. So, question for you. You can keep tabs of your own score here. If we cut carbon emissions to 0 today, we could stop the warming. Is that true or false? That's kind of important, actually. If we continue with the current rate of emissions, global mean temperature will rise by 2 degrees by 2100. Is that true or false? If global mean temperature rises by 2 degrees centigrade, that's no big deal. Canada is warming faster than the equator, and a warming Arctic is not a threat. So are these true or false? And we'll kind of deal with them over the next few minutes, but I'll give you the quick Coles Notes version here. If we cut carbon to zero today, warming will continue because of the indefinite duration of carbon dioxide in the atmosphere. So even if today we went to zero, we're already on a warming trajectory and it ain't going to stop. We can mitigate it, but we cannot stop it. If we continue the current rise of emissions, GMT will rise by 2 degrees. That's false. It's going to be of the order of 4 to 5 degrees. If it rises by 2 degrees, that's no big deal. If it rises by 2 degrees, many people, most scientists think that's a very big deal. And I'll show you why in a minute. Canada is indeed warming faster than the equator, and the Arctic is warming faster than any place on Earth, which has huge implications because it's a massive store of methane in the permafrost in the Arctic, which we do not want to have released. And a warming Arctic then is very definitely a threat. So the International Panel on Climate Change, which is a UN body, monitors the science on global warming, and it publishes regular reports. And this graph it's really important for you to see this graph. So what this is global mean temperature anomalies in degrees centigrade from 0 to 6 degrees centigrade. And across the bottom are the years from 2000, 220, 240, 260, 280, 2100. These lines, this is representative concentration pathway 2.6 and RCP 8.5. And what they're plotting is the change in energy absorbed by the Earth with different concentrations of greenhouse gases. RCP 2.6 is the modeling for us dramatically reducing carbon dioxide levels right now. And that's the blue line. So if we look at that, you can see we're here, that even if we stopped right now, the warming will continue out to 2100, but it will stay, we hope, below 2 degrees centigrade. And that's what you keep hearing about in the media, that to holding warming to under 2 degrees. The red graph, the number of different lines or different models which are used, the red graph is if we continue as we are at the moment with no change and no mitigation. And the trend line here, if you take the average of all these, is very clear. We'll end up with about a 4-degree rise by 2100. And that's the projection. So you might say, if you're sitting in the snow, warmer sounds good. It really isn't. And so I really want you to emphasize this to you. Global mean temperature of the world taken as a whole is 14 degrees centigrade. So a rise of 1 or 2 degrees with a denominator of 14 is a very substantial rise. It's not a small rise. Most scientists feel that we're currently 1 degree or more above pre-industrial temperatures. At plus 2 degrees, some countries will do well and some won't. Canada may actually do quite well with a longer growing season and more carbon dioxide in the atmosphere, which helps plants grow. At 3 degrees, it's felt that we're all going to lose. And at 5 degrees, there's a very serious risk of species extinction, including our own. So we really do not want to get to that possible figure by 2100. And it's really difficult to get your head around this. When you see this stuff and you realize it for the first time, you say, can this be true? That we could actually be looking at that level of threat over the course of the lifetime of one of our grandchildren. A child born today could actually face this level of threat. And you really can't get your head around it. And it's very difficult to believe it. But that's the scientific consensus at the moment. You may have seen David Attenborough's report to the UN yesterday. So I think it really is real, and it's difficult to believe, but unfortunately true. So climate is not that articulate. It doesn't have a huge range of vocabulary, and it talks to us in terms of temperature and rainfall. And temperature and rainfall are related, of course, because warmer air can hold more water. So it changes precipitation patterns. And it also changes ocean currents and chemistry and storms. There's some debate about whether it causes more storms, but there's not so much debate that the storms which do occur are much more powerful and intense. This is an important graph, and I just want to walk you through it. And it's important for you to see this, because this is the projected future for the world. And what it shows up here is mean temperature change at 1.5 degrees centigrade of global mean warming. And over here is mean temperature change at 2 degrees of warming. Down here is mean precipitation change at 1.5 and again at 2. So if we look at this graph first, and the lighter colors are not so warm, and the darker colors are much more warm, up to 8 degrees. So have a look at this map and see what you see. Well, the first thing you see is that the oceans are warming less than the land because they have an ability to buffer the temperature. And that's important. So remember, when people talk about a 2 degree centigrade mean rise in temperature, they're talking about the whole world, including the ocean. A 2 degree rise in the whole temperature means that some areas of the landmass are going to warm at a much higher temperature than that. And if you look up here at Canada and the Arctic, you can see that indeed we are warming faster than any place else. And the Arctic is really warming at up to 5 times the global average. So a general rise in temperature, except the oceans, particularly marked in northern Canada. And so how does that translate into a change in precipitation? So let's go down here, and the darker colors are drier and the bluer ones are wetter. So if we look at Canada, the projection is that there will actually be increased rainfall over parts and snowfall over parts of Canada. Southern Ontario may get a little bit drier, but in the short term, we're probably going to do okay. We'll have warmer temperatures and more water. So we might be all right from a crop production point of view. The southwestern United States, on the other hand, is going to turn into a desert. And it already is. And you're seeing that with the wildfires and the other manifestations of it. That dry band extends across Central America. The Mediterranean is going to turn to a dust bowl, and that will spread into Turkey and the West Asia. That dry band extends down the west coast of Africa into South Africa, and then in East Africa, it increased precipitation and flooding. And you may remember a couple of months ago, very serious floods in Sudan and Ethiopia. And one event, you can't necessarily say that it's related to climate, but the pattern is most certainly there. And you can see it in California and New Mexico, across the Mediterranean, North Africa, and into East Africa as well. So temperature change is projected to very dramatically change precipitation. And when we change temperature and precipitation, we change the fundamentals of human existence, which is air, water, and food. So as temperature rises, the projection for corn is that crop yields will go down, and the same for soybeans. There's a sweet spot for these crops around about 20 degrees, 22, 23 degrees centigrade. And if you go beyond that, crop yields decrease for both of these, and for rice and maize as well. So for many of the crops which are fundamental to lower income countries in the equatorial region, the projection is that as temperature rise, crop yields will go down. Not only will the amount of crops being grown go down, but the nutritional value of the crops will decrease as well. So this is percent change in plant nutrition between 380 CO2 and 550 parts per million for zinc, iron, and protein. And if we just look at wheat, you can see a almost 10% reduction in zinc, 5% in iron, and 6% in protein. So this has a huge implications for nutrition especially in lower income countries where nutritional status is already often very compromised. So the argument so far that I'm making to you, we're going to get to surgery in a minute, don't worry. Global greenhouse gases are reaching an all-time high. Greenhouse gases are warming the atmosphere. There's no debate about this. The science of this goes back to the 1800s. A warmer atmosphere changes climate and weather. That's not really up for debate either, which results in changes to crops, water, and infrastructure, and these will affect poorer countries disproportionately. I think these arguments are pretty solid, and you would not easily be able to refute them. So let's move on to health. and talk about that and move into surgery, which is a more direct interest to you. So at the center of the health issue here is increasing CO2 levels, which leads to rising temperatures and more extreme weather and rising sea levels. And as I mentioned before, the same things which drive temperature rise pollute the air. So when we burn petrol or gasoline going to work, we're not just producing carbon dioxide, we're producing particles and sulfur and other things as well. Changes in vector ecology are a concern, particularly patterns of malaria, which are changing in Africa. Increased allergens in Canada because of a longer growing season. Decreased water quality because of this heavy rainfall, which can pollute reservoirs. Even Vancouver is reporting increased levels of cryptosporidium in association with high rainfall events. A city as wealthy as Vancouver is sometimes struggling to deal with it. So there will be water and food supply impacts, associated with environmental degradation, and we will have to deal with extreme heat, particularly in cities where you get heat islands. And then there's the severe weather events, which have the potential to damage infrastructure. So here's the question then, or one very important question. Why do doctors know so little about this? There are two possibilities here. One is what I'm saying to you is complete nonsense. And the other is that it's true. I think it's true. And if it's true, why are we not taking this on as a public health issue? So if you go to PubMed and you type in climate change and health, and 1922 up to now, there's nothing until about 10 years ago. And then the papers start to appear, a little trickle, and not very much. So it's not on most undergraduate curriculums. It's not on most postgraduate curriculums. So what has happened here? How did we get so siloed and segregated from this? I don't know, but I think this guy's comment on it. William James is the founder of, one of the founders of psychology. And it's a new idea is first condemned as ridiculous, and then dismissed as trivial until finally it becomes what everybody knows. So I think we're somewhere between ridiculous and trivial, but it's changing fairly quickly. So how might climate change impact surgery? And I can only speculate on this because there's very little written on it, actually, that I could find. Well, the possibilities are that it would change disease patterns. I don't think so. I don't think you're going to see any fundamental change in the types of disease that are coming into you. There is no signal there that I can see, and I think that's unlikely. How about the preoperative health of populations? There is a literature on this, that as the air changes and more pollution and so on, that your population will become less healthy. I don't know what the significance of that is. The particles, PM2.5, particles 2.5 microns, are up there as a cause of cardiac disease and respiratory disease, but we dealt with smoking, sort of. This is kind of the new smoking, maybe. I don't know what the impact will be. Patient population, Canada will be an island for migration, so you may see different diseases, but I'm sure you can cope with that very easily. Infrastructure loss, maybe. I mean, we were closed down in Halifax with a hurricane a few years ago, but it's rare enough. London, I suppose, might be vulnerable to tornadoes and the like, but I can't imagine that it would be a huge daily occurrence. The pandemic is one to think about. There is a literature linking COVID to what we're doing to biodiversity and the climate and to encroachment on wilderness. So I'm not sure about COVID, whether it's a once in a 100-year event or whether it's a canary in the greenhouse, and it's giving us a warning that we need to change our behavior in terms of impacting on biodiversity in the environment. I think the main one is going to be practice change. So if I was to speculate on how climate change might impact surgery, I think it's over here. It's practice change. And you're going to be asked to change your practice over the next 5 to 10 to 15 years. And I'll show you why that might be so. This is a really beautiful paper, and we're going to spend a little bit of time on it. And it's the impact of surgery on global climate, a carbon footprinting study of operating theatres in 3 health systems. And the lead author is from BC, AJ McNeil. Division of General Surgery at UBC. I don't know Dr. McNeil, but perhaps I'm sure some of you do. And what they did is they did a study comparing 3 hospitals: the Vancouver General Hospital, the University of Minnesota Medical Center, and the John Radcliffe Hospital in Oxford. The area of these 3 operating room suites is similar: 1,650 square meters, 1,450 square meters, and 3,049. But the reason the Radcliffe area is so big is they have a separate anesthetic induction room. So it's really not that much bigger. Cases wise, 22,000, 18,000, and 30,000. So they're certainly putting more volume through the Radcliffe. And they looked at 3 areas which were relevant to climate change: volatile anesthetic gases, heating, ventilation, air conditioning, and waste. And they broke it into this municipal, solid, domestic, hazardous, fluid, sharp, cytotoxic, black box, which is toxic chemicals, recycling, and reusable. A really, really beautiful study. The study was done in 2011, I think, but it wasn't published until 2017 for some reason. It's a very complex piece of work, and it's an extraordinary thing to see. So let's look at anesthesia. And CO2e means equivalence of carbon dioxide. So because carbon dioxide is the gold standard for greenhouse gases, everything's related back to CO2 as a sort of standard measure. So it's called CO2 equivalent. So at the John, look at this for a dramatic difference. At the Radcliffe Hospital, the anesthetic carbon dioxide equivalent per case is 7 kilograms of CO2. But at a Vancouver General, it's 92.5 kilograms. And at the University of Minnesota Medical Center, it's 118 kilograms. I mean, that's a pretty impressive difference in anesthetic CO2 per case. And the authors postulated, or said actually, that the reason is, you probably already figured this out. Maybe I'll leave you in suspense. No, I won't. The reason is in the UK, they don't use desflurane. And desflurane is 2,500 times more potent as a greenhouse gas than carbon dioxide. And they use isoflurane and sevoflurane instead, which have greenhouse warming potentials of about 150 and 500 respectively. In North America, on the other hand, desflurane is fairly standard, and it's contributing to this huge carbon footprint. And in terms of energy, operating rooms are very energy intense because of the needs for climate control. In megawatt hours per meter squared, the Vancouver General 2.2, University of Minnesota 2.7, and the Radcliffe, the worst, at 3.5 in terms of energy expenditure per meter squared. And what they said here is VGH gets credit for using hydroelectricity and for having setbacks on its heating and, or at least its air conditioning and lighting in the operating rooms. The Radcliffe, on the other hand, is a very old building and uses coal-based electricity for its energy supply, so it gets dinged for that. And if we look at waste, and I think your resident has photographs to share with us of waste, the Radcliffe is producing 7.7 kilograms per case, Minnesota 11.92, and a Vancouver General a staggering nearly 16 kilograms of junk per case, per patient through the door. So the carbon intensity per operation and total CO2 in these 3 quaternary hospitals for Vancouver General is 146 per case, kilograms, Radcliffe 173, and Minnesota 232 kilograms of rubbish, of waste per case. It's unbelievable. I mean, it's absolutely extraordinary numbers that of what we're producing and throwing out. So here's the 3 footprints of the hospitals, and you can see that they're very different. For the North American hospitals, anesthetic gases are around half of the carbon footprint of the total, whereas in the UK, the anesthetic gases are just a fraction, and it's their energy that's causing the problem. So like human fingerprints, likely every operating room has its own fingerprint in terms of its carbon emissions. But I thought about how could I how could we understand this? I mean, what does 146 kilograms of carbon dioxide mean? I don't know what 146 kilograms of carbon dioxide is. What is it? Well, so if you do the math, and again, I keep checking this, and I'd be grateful if you check it and tell me if I'm wrong. 146 kilograms of carbon dioxide translates to nearly 90,000 liters of carbon dioxide gas. And if you want to think about it in party balloons, and each one of these is 1,000, and each balloon is 14 liters, it would be 1, 2, 3, 4, 5. 5,000 of these horrendous 14-liter balloons being released into the air per case that you do in the operating room. I mean, it is absolutely staggering in a sense. But here's another comparison for you. And I'm not sure how you're going to take this one, but let me try it anyway. So 146 kilograms of CO2. If the average Canadian car has a gas tank of 60 liters, and 1 liter of gasoline generates 2.4 kilograms of CO2, one tank of gas generates 144 kilograms of CO2. So you're roughly doing 1 tank of petrol per surgical procedure at the Vancouver General Hospital. You might say, well, that doesn't sound so bad. I think actually it is bad, but what's conning us is that we think the car is okay, and it isn't okay. It's a huge part of the problem. So if we were going to actually look at London or one of the surgical suites in Southern Ontario, you should probably start with how you got to work in the morning. And one of the main offenders, I mean, the operating room is certainly important, but one of the main offenders is your parking lot outside the door and the gasoline that's burnt as we move back and forth. We've gotten so used to this incredible source of energy, we're kind of spoiled. So to finish up, what can you do? And I think the answer is you can do whatever you can. I think it's worth, I hope I've convinced you that it's worth educating yourself on this topic. It's not a nice topic, and you need, you need to be resilient to take this one on with everything else. However, we owe it to ourselves and to others. So you can educate yourself. If you're involved in the undergraduate curriculum, you might consider trying to get that onto the undergraduate curriculum. Dalhousie is having a meeting tomorrow night on the future of the curriculum, and it's on climate change. You can get it into postgraduate training if that's what you're involved in. And if you're a member of CAGS, you might ask them to put this on for the annual meeting occasionally and get this on there as a topic. You can advocate for change and you can talk to your peers. There are professional organizations involved in this, including the CMA and the Ontario Health Association. You can talk to the public, and really, most importantly, politicians, because the decision-making is with politicians. And they have an immensely difficult job to do, to wean us from our fossil fuel dependency and wean the economy onto something radically different over the next 20 to 30 years. And so they need our support. And physicians are respected. And when we talk to politicians and when we talk to the public and we talk to the newspapers, it has an enormous impact. And support younger faculty. This could still be a career limiting topic to get into to some extent. The older generation of physicians are not necessarily, and some of the younger ones are not necessarily on side with this. And it can be a bit intimidating for junior faculty to move into this area, but I think it's worth supporting them. Bill Gates published his book last week, How to Avoid a Climate Disaster. It's very readable and very logical, as the usual way that Gates is. And so I'd really recommend that book to you. I've been reading it, and I think it's a wonderful summary of what's going on. So why do it? Well, it might make a difference, which would be good. It might be the most important medical intervention we ever deliver. It'll encourage others to join in, especially young faculty. It'll support your political leadership, whose task is unenviable, and you will be able to look the next generation in the eye. And I do mean that. If you have children or grandchildren or whatever, I think we're all going to be called to account for what exactly were we doing when we knew this was happening. This is a real question, and we need to engage in it. So with regard to how might climate change impact surgery, I don't see it on disease patterns or preoperative health or the patient population, infrastructure loss. The pandemics, I'm keeping an open mind on. I'm not so sure that COVID is a once-off. I hope it is. But given what we do in terms of farming pigs and chickens and packing them in together and allowing viruses to move between these animals, I'm not so sure that we've heard the last of this. I think the main thing will be practice change, and you'll be asked to have a look at the operating room with regard to how you can impact the hospital's carbon footprint. So the messages that I have for you is that climate change is underway. We really do need to get on with this. I mean, we're in an 80 to 100 year time frame to some serious outcomes. It is a health issue, and surgical practice will be affected. We need to get more involved as a physician community, and we really need your leadership to help drive change. So I wouldn't for a moment think that any of us is in a position to make perhaps an enormous difference here. And I think what we can do, though, is be a little part of the picture. In other words, a pixel, and we can help contribute to change and lead it in a positive direction. So thank you for that. And again, thank you very much for the opportunity to talk to you. I look forward to the discussion.
Thank you, Des. That's, wow. It's a lot to digest first thing in the morning, and that big picture about what this world will be is quite enlightening. I know that Sydney's going to share her screen and do her case presentation. So we'll let Sydney bring up the screen. As we go along, there's some comments in the chat section that we'll talk about. There's no questions there yet, but will be coming.
Well, I only have just a couple slides here. I have a couple photos from different ORs that we do at LHSC, just kind of showing the trash that we produce in the ORs, and then just a couple words about what happens to it from what I've been able to find out. As we already talked about, the actual physical garbage and waste is not the largest contributor in most of these cases. We do we use sevoflurane and desflurane in LHSC as well, which as we just saw is a large contributor, but this trash is a very visual kind of reminder of the waste that we're creating. So I think it's very striking. So this picture here is from, well, let's see if it's working here, a lap coli. This was at Vic. Our next one we have here is from a kidney pancreas transplant. So you can see there's about 6 bags of garbage there. And again, none of this is including the biohazard or the recycling, although the recycling is not usually so prominent. I think most of our stuff goes into these clear trash bags, which are destined for the landfill. This one here, if you ignore the linens, that's about 3 bags worth of garbage from a laparoscopic liver metastasis ablation. So a single liver met, they're producing about 3, or I think there was maybe 1 more bag under there, so about 4 bags of garbage. And the last one here is just 1 umbilical hernia repair, about a half-hour case there, and you can see 3 kind of full bags of garbage. Want to thank Louise in Environmental Services, who I called up during the middle of the day to bother about what happens to our trash at LHSC. So our garbage and actually our recycling, I don't know if anyone else has noticed, we have like a blue bag in the OR for recycling that I rarely see get used, but most of the stuff goes into the clear trash bags, which are destined for the garbage. We have compactors on each campus, so they get compacted at the hospital, and then those compacted garbage kind of cubes are taken to the landfill. Our biohazard, our sharps in the ORs, there's like the black kind of containers there. Those are contracted out to a company called Daniel's Health, and they are incinerated, as was mentioned before. I was not able to get in touch with Daniel's Health to find out what happens to their, like how they incinerate their garbage, but as you can imagine, that releases some serious gases into the atmosphere. I'm not certain what other people's experiences are, and I didn't look into this particularly, but I had noticed that a lot of oftentimes some biohazard gets taken into the trash versus the other way around, something like Foley bags at the end of a case or something. I'm not certain that we end up throwing a lot of our non-biohazard into the biohazard bag, but I don't know if anyone wants to speak to that in their experience in the OR. Regular trash kind of going into the biohazard. But we can talk about that in a second. And then just the next slide, just to talk about here are anesthetics. So as we talked about, one of the largest contributors to greenhouse gases from our ORs are actually from the volatile anesthetics. I would highly recommend that podcast that was mentioned in the chat. Dr. McNeil is very interesting. Desflurane, as was mentioned, is the kind of worst offender in terms of greenhouse gases. It's less commonly used now at LHSC. Sevoflurane seems to be the anesthetic of choice. Isoflurane, less commonly so. It has a longer onset and offset time. So just for convenience's sake, it seems as though sevoflurane is more preferred. The other options are also nitrous oxide, but that I don't believe is used at all at LHSC. In terms of what happens to the volatile gases, the system is designed to scavenge kind of any gas that isn't absorbed by the patient and then kind of recirculate it back into the patient during the maintenance phase of anesthesia. But of course, these are not, kind of airtight circuits. So much gas is released out into the air of the OR and then out into the atmosphere. And the CO2 that's exhaled by the patient, there's a CO2 desiccant on you can see the little container on the bottom of the anesthesia setup, aiming not to recirculate that CO2 back to the patient. But again, these aren't kind of perfect circuits, so some CO2 will leak out. But as was mentioned previously, kind of the biggest offender there is the volatile gases in terms of contribution to greenhouse gas emissions. And that, I think, is pretty much all the information I have about our waste at LHSC. I don't know if there's any specific questions about that or just questions in general.
Yeah, we're going to come back to that. I'm going to share my screen for a minute, and then we'll get to some of the questions.
Shoot, how do I stop share? Here we go.
So share. Everybody see that? So we've talked a few about Dr. Andrea McNeil, and she's a young oncology surgeon. And actually the paper that Des talked about was her master's project. She's done a master's in health sustainability out at UBC. And these are some of the highlights. There's a few ways that you can hear about Dr. McNeil. She did a recent Cold Steel podcast, which is outstanding. And she gave a plenary lecture at the Ontario Association of General Surgeons in 2020, and that's still on their website live. But some of her highlights was that healthcare accounted for 4.6 of the global CO2 emissions compared to aviation, which is 4.9. She said if healthcare was a country, it'd be the 5th highest emitter. Healthcare in the US accounts for 10% of all emissions. And Canada's healthcare, we rank number 3rd compared to all the other healthcare systems for emissions. So quite huge. She looks at it from a number of factors, starting off as reduced demand for healthcare services. We, of course, can't make CO2 if we're not producing. So there was a lot of that about global health and things to do to make a healthier society. Talked about the appropriateness and the method of care. Certainly, a lot of the studies through Choosing Wisely say that 30% of the things we do are not required. And then, of course, this pandemic has shown us that virtual care and changing methods of care decreases the carbon footprint. And then the sustainability, which was a lot of her project. And she broke it down into energy, anesthesia, and consumables. As you hear her talk, within the OR, it's the HVAC system that creates a lot of issues. The anesthetic gases, as Des talked about, and then the consumables. And in her talk, it's just not about the recycling, it's the whole
Ken, I can't hear you.
Dr. Leslie, I think your mic is stopped working there.
Maybe while Ken's fixing that, can you hear me, Des?
Yeah.
So Des, a couple of the questions on the chat were about comparing cloth drapes to disposable drapes in the OR. And there's some, Steve said there's some study comparing cloth diapers to disposable diapers in terms of they have different patterns of energy use and emission. Have you anything on that, or?
No, I don't. I mean, the only comment I have on that, Vivian, is that people talk about life cycle measurements. So if you use cloth, for example, you need to look at where it came from, how it got there, how it was manufactured, how it's laundered, all of the outputs that are associated with that, and like for like. But I suspect that it probably is more environmentally friendly, but I don't know. I didn't look at it. I don't have any data on it.
And I don't know if our St. Joe's surgeons want to turn on their mic and say, we have a history in one of our hospitals here, Des, that was run by the nuns. And as you know, they're a very frugal bunch. And they refused to go to disposable drapes. And I think it still continues as a tradition, even though we have very few nuns left in the hospital, that in that hospital, they're using reusable drapes as much as possible. And it would be interesting from a resident to tell us, or others, are they using the recycling bags more often? I don't know if a surgeon from St. Joe's would like to comment.
Vivian, it's Meryl Blackstone here. We do still use the reusable launder drapes at St. Joe's. We have some over drapes that are disposable, but for the most part, it's still laundered. But I don't think that there's a real emphasis on recycling there at all as of yet.
Hi, it's Chris Finnan. When the switch was made at LHSC, the company Cardinal that was pushing the paper drapes had all these life cycle analyses that suggested that their paper drapes were better for the environment than laundering things. I must say, when it comes from the company, I'm usually very highly skeptical of these things, and perhaps someone needs to relook at that thing. I do know, I actually toured the laundry facility. It's all fossil fuel heated water and fossil fuel dried drapes. So you'd have to take a pretty close look at it to know whether you are helping the environment. But I must say, as a surgeon who worked there for many years, I much prefer the cloth drapes.
Yeah, no, Chris, I think you're right. I mean, I think you have to look at the whole thing. Now, institutions are engaging on this institutionally. The Cleveland Clinic seems to be a leader. The University of Melbourne, where I have some connections, have also set up a group. But it needs a multidisciplinary approach. I mean, you need the engineers, and you need the heating guys, and you need the anesthetists, you need the surgeons. You need a whole group if you're going to move forward. And you can also argue, you know, why are you starting in the hospital? I mean, the parking lot is a major problem. And so we have a massive societal transition to make over the next 10, 20, 30 years to move from a fossil-based economy to something else. And so the change is going to be quite enormous. And I think it is surely coming. And we need to engage with it and help manage it.
Just a comment, I suspect a virtual clinic is going to have a much bigger impact on the environment and reducing carbon emissions than is what we do in the operating room. But
yeah, very likely.
Does anybody know about the project still going on at UH? That was one of the questions. There was that article that was first presented about the diversion. Does anybody know if that's still going on? Doesn't look like it from Sydney's garbage.
Ken, it's Julianne. I did talk to Doug Noddy a couple years ago about potentially looking into kind of a green OR committee, and that project that Johan had started with him, it's not active. I think that was kind of a one-time shot to try to implement change, but I certainly don't hear any talk about that should go in recycling or that should go in the garbage at UH.
Well, I mean, I think that project 10 years ago in London was a decade ahead of its time. I mean, it was timely, but the environment wasn't ready for it. It wasn't a receptive situation. I think it's very different now, and within the next 5 to 10 years, I think it'll be different again. So probably time to consider reactivating it.
I think
Vivian here do you know why they don't use desflurane in England and we seem to use it all the time? I don't know if anybody else knows what, you know, it seems like a huge difference. And I know the isoflurane is cheaper than SIBO, but
the explanation I saw is that the induction with desflurane is faster and wears off faster. So you trade time for cost, and I suspect that the environmental impact is not really being factored in at this point, but it probably will soon. So I think it has to do with speed of induction and recovery.
And certainly it's not used in some hospitals due to the cost. It's very expensive compared to the other volatile gases. So that's likely why the NHS was smart enough not to bring it on.
yeah.
Des, do you know whether those hospitals were using recycling units for their anesthetic gases and recovering them? Like there was a paper out of Edmonton that showed, you know, they were not using it and had a massive carbon footprint, and they just all of a sudden just said, we have to recirculate this, and they dropped their usage like 99% or something.
Yeah, it's an interesting area, and you'd be surprised at what's going on. It turns out there are monitoring stations on the top of the Jungfrau mountain in Austria, which measure halethane and isoflurane and desflurane and all the other gases. And what they've shown is that halethane, of course, is disappearing as it's not used very much, but the others are rising. So there's a whole science behind this that is really fascinating.
Des, we just put the poll up again.
Oh, I live and die on this one, Vivian.
Now we know that it's the same question if you quickly choose your answers. And then the big test for us will be if Christine can show us the results of that while we wrap up the conversation. Ken, we're at 8:05.
Yeah, I think looking at the chat, we're doing really well. I fully support Des. I think we need to encourage our young faculty and our residents to get involved with these projects. As a division, we've done really well with quality improvement, and this just kind of comes right off of that. The better quality that we do, it's all wrapped together. It's hard to see how little projects will impact the world, but as Des said, you got to start somewhere, and everybody's got to get engaged. Certainly, there's great master opportunities, there's great projects, there's infrastructure, as Sydney found. There's people within our organization that will help out. It's more just the drive to do it and to get it done and get the projects going. So if anybody's interested, certainly we have the infrastructure and the support to help our young to move forward and be leaders in this field.
Yeah.
I think I heard Julianne volunteer to head that up for us.
So if there's no other questions, we'll thank Des for being our first SWASA guest and the presentation to start us off. The goal is looking forward to 2050 and see what impact that we can do in that 30-year period.
Great, thank you. Thanks for the opportunity to speak to everyone. Thanks, Ken. Thanks, Vivian.
Thank you, Des.
I'll take the next 5 minutes to try to share my screen. What I don't have in my office is always very good internet, so my sound goes. And of course, I just hear myself talking. So please let me know. Just an FYI that starting next week, there's a green bin project that's going on at University Hospital. You're going to see these green carts in the OR, and all the sharps and disposable instruments are going to go in there. Daniel Medical, as you heard before, looks after our sharps. They're going to take all this debris, and then some of it will be reprocessed. Some of these instruments can be reprocessed, cleaned, and reused and get on the market to be sold. So that's why it doesn't cost us anything. And the other parts that can't be will be diverted to their landfill. If anybody wants to be involved with this project or do some science around it, let me know. But this is starting next week, just at University Hospital. The hope is, as they figure out how it works, that will get moved across to Vic. So that's a new project just starting. So just to talk for 5 minutes a bit about SWASA business, just for a little bit of history for everybody. SWASA actually started in 1954 by Dr. Angus McLachlin. Just to give you a little history about who we referred to as the chief. He was born in 1908 in St. Thomas. He captained the Western football team. He was a Rhodes Scholar and did a PhD in physiology, completed his surgical training in Toronto, and then was a military surgeon in World War II. He came back and was professor and chairman of surgery for 30 years here at Western. He trained the majority of surgeons in our area and a famous figure. And you'll see his portrait still up at University Hospital. These rounds are started up as a fallout from the pandemic and something that we really want to spread now. The aim is to reach out to the community. We want a lot of community involvement. We want the community to suggest topics to us about what they would like to listen to. So Vivian's got that organized. And the next session is March the 17th with Dr. Braxton about the management of the axilla. For people to realize, we're starting a centralized colorectal referral. It's starting March the 1st, which is next Monday. It's a collaboration with the Southwestern Regional Cancer Program. And the technical name is what we call the OPNP, which is the Oncology Patient Navigation Program. The former name for that program was the DAP program. It's now the OPNP. And the goal is, of course, to provide better patient care, better seams through the system and better support through the system, and a better cancer journey and a more efficient cancer journey for the patient. They can enter the program by 3 ways: faxing the referral form, using our GenSurge Onc email that we brought in during the pandemic and is still going on. And there is a common OPNP order set that can go into. So this is what the referral form looks like to be either emailed or faxed. I couldn't figure out how to share screen the OPNP order set, but if you put in common OPNP order set into PowerChart, you'll find it. How it works is that there'll be a triage surgeon accessing all the cases. The OPNP nurses will navigate the diagnostic workup, and then the new patients will be assigned based on subspecialty need, wait times, MDT participation, and historical volumes. And with any new system, we want a lot of metrics to ensure that it's doing its job. There'll be metrics about their workup, their wait ones, wait twos. We'll have their NISQIP output data from it, MDT participation, and of course, patient satisfaction. So that's the new system starting up next Monday. So if there's any questions, let me know. And then, of course, I'll stop sharing my screen. And I want to give thanks once again to Dr. McAllister and our guest speaker, Dr. Leddin, for coming and talking to us today, and to Christine for making this work. Any final comments, Vivian?
No, thanks, Ken. I hope, looking forward to Muriel's talk next month. And we have our slots lined up for the year, and we'll hopefully have the AJ Grace lecture maybe in June, which will be the highlight of our year. Thank you, Ken. I think you're gone again. Your Ken's mic is off again. If anybody else wants to add to the thanks, otherwise, I think, Ken, you're going to adjourn the meeting, are you?
Yes, correct. Thank you, everybody.
Very good. Bye. Thank you.
Thank you, Des.